So let's move on to the next thing. We have talked about the definition and example. So we want to talk about oxidation numbers and the rules that guide the oxidation number. Now, your understanding of this topic depends on this number two. So let's pay attention to this number two very well, and I'll give you some questions at the end of the day. So, oxidation number and the rules that guide oxidation number. So, first thing is, what is oxidation number? Oxidation number is an indication of the number of electron loss or gained during chemical reactions. For example, now if I write Na plus, you already know what that means. That means this guy gains lost one electron. If I write O2 minus, what does that mean? That means this guy has gained 2 electrons. If I write Al3 plus, that means this guy has lost 3 electrons. So that is what we call oxidation number. So the oxidation number of this guy is +3, that of this is -2, and that of this is +1. Now, when you see elements, let's say I have CaCO3. If you look at this compound, we might need to determine the oxidation number of calcium, carbon, oxygen in this compound. So that's why you have to understand these rules very well. So what are the rules we use in determining oxidation number? The moment you understand these rules, then this topic will become easier for you. So number one rule is that you have to understand that most group 1 elements, they have oxidation number of +1, group 2 have +2, group 3 have +3, and so on like that. But these ones are very important. Anywhere you see fluorine, that means that anytime you see fluorine in any compound, the oxidation number is always -1. So if I write HF now, and I ask that what is the oxidation number of fluorine here, it is -1. So no doubt, everywhere you see fluorine in a compound, it is always -1. Then rule 2, everywhere you see hydrogen in a compound, it is usually +1. So you need to note that everywhere you see hydrogen is always +1, except in, so the exception is in metallic hydride. So we have what we call metallic hydride. So metallic hydride is a metal that is joined to hydrogen. We call it metallic hydride. For example, if I have sodium hydride, so this is sodium hydride. This is a metal joined to hydrogen. So if they ask you for what is the oxidation number of hydrogen in this case, it is -1. So anytime you see hydrogen joined to a metal, the oxidation state is always -1. But anytime hydrogen is in another compound, let's say in water now, in A2, if I ask that what is the oxidation state of hydrogen here, it is +1. What is the oxidation state of hydrogen in H2SO4? It is also +1. Do you understand that? But anytime you see hydrogen joined to a metal, then the oxidation state is always -1. So that's rule number 2. Rule number 3, oxygen. Everywhere you see oxygen, it is always -2. So if you, in this case, now if I say what's the oxidation state of oxygen here, it is -2. What's the oxidation state of oxygen? It is -2. So every time you see oxygen, but we have exceptions. So the exception is that in peroxide, so if you see a compound and that compound is peroxide, the oxidation state of oxygen is usually -1. So if I give you hydrogen peroxide, for example, H2O2, and you see that, oh, this compound is a peroxide, you can also do the calculations to determine that. We are going to see that as we move on. Now, if this compound is a peroxide, so if I ask you that what is the oxidation state of oxygen here, then you say it is -1. Do you get that? Every time you see a peroxide, that is it. Another example is that in superoxide, there's what we call superoxide. So there are some compounds, oxygen can form monoxide, basic oxide, superoxide, and all of those things, and peroxide. So in superoxide, the oxidation state is usually -1/2. Just note that one. But aside these two, everywhere you see oxygen, it is always what? -2. Now, so let's say I give you a compound like this, CaCO3. So I ask you, what is the oxidation state of oxygen here? Very good. So it is going to be -2. So number 4, every time you see an element on its own, let's say I just have chlorine, it's not joined to another element, and sodium is not joined to anything and is not carrying any oxidation state. So if I say what is the oxidation state of this guy, then you will say it is 0. It is 0. So for elements on its own, the oxidation state is usually 0. You will see how useful this thing is. It will help us to do some calculations, and it will also help you to determine, they can give you a list of reactions when we start solving past questions and say that which of the following is not a redox reaction. So when you know these rules, you will be able to determine that. So number 5, the sum of all of the oxidation states, you can write that in as a note. The sum of all of the oxidation states of all the individual elements or atom in a neutral compound is 0. So the sum of all of the oxidation states in a neutral compound is 0. You can always pause or rewind it in order to write the notes of what I just said, so that I won't be repeating it over and over. So the sum of all the oxidation states in a neutral compound is equal to 0. So what does that mean? That means that if I have, let's say I have a compound that have elements with variable oxidation states like KMnO4, then if I sum all this compound, now when you don't see a charge, maybe plus or minus here, we call this compound a neutral compound. So this guy, this guy, when I sum their oxidation states all together, then everything will give me 0. But now manganese is an element that can have variable oxidation states, and we call it a transition element. But potassium is a group 1 element, and when I started, I said group 1 elements usually have oxidation state of +1. Do you get that? So let's say I don't know that of manganese because it has variable, it can have different oxidation states. Then you make that, let's call that X plus X. It said that the sum of all of the oxidation states. So I want to sum everything. That of potassium is 1. That of manganese, we call it X plus 4 into, I said anywhere you see oxygen, the oxidation state is always what? -2. Do you get that? So now, which means we'll put -2 here. Then that will be equal to 0. Do you understand that? Then you can now say 1 plus x minus 8 is equal to 0. Then we can say 1 plus x is equal to 8. Then we can say x is equal to 8 minus 1, and that is equal to +7. Now, quickly, you need to note something. The oxidation state of manganese here is +7. So if you want to name this compound, there's a common name for this compound. We call it potassium permanganate. You will see it in your past questions when we start solving. Potassium permanganate. So you need to get used to that. But now, in general, this is called potassium. How many oxygen do we have here? 4. So this will be potassium tetra. Tetra is 4. Oxomanganate 7. So the oxidation state you see here belongs to manganese. So that's why the name is potassium tetraoxomanganate 7. So can you do for me to solve for K2Cr2O7? So this is called potassium dichromate. So solve for chromium here. There is V2O5, solve for vanadium here, using the rule I've used here. So if you miss it, I'll do the correction. So let me see what you have. Also in H2SO4, sulfur can have variable oxidation state. So sulfur here, and name the compound. So this will be potassium heptadichromate 6. But try to solve for the oxidation state from what I just told you. Then the next rule is that the next one is sum of all of the oxidation states of an ionic compound is equal to the charge carried by that ion. So sum of all of the oxidation state of an ionic compound will be equal to the charge carried by the ion. So what does that mean? If I have MnO4 2 minus, now because there's 2 minus here, now this is called an ionic compound. So I can sum all of the oxidation states. So I can say, let's say I'm looking for manganese here now. So I'll say X plus 4, oxygen is -2, will be equal to the charge carried by that ion, -2. Do you get that? So now I can solve for X. So I can say X minus 8 is equal to -2, right? So I can say X is equal to -2 plus 8, and that is +6. So this is tetraoxomanganate 6 ion. So that is what we have here based on the calculation. How about if I have Cr2O7 2 minus? So you have to solve for Cr. Now let's look at this compound. I don't want to make it look complicated, but for now, let's look at this. Because of this charge here, so you can calculate for this guy. I'll come back to that. I'll come and teach that in another video in order not to waste time, so that you see how we do it. It's the same thing. This is called a neutral compound, so it will have oxidation state of 0. Chlorine will be -1. So you can sum everything to see how you are going to get for this guy. So How about if we have let's say I have S2O3 minus sulfur here. So following the rule I just used, the example I did here, solve for that too to see if you are getting it. We are going to apply it as we are moving on. So the next one, the last one that I feel you should know is this, that in some compounds, some elements have different oxidation states in the same compound. For example, in Fe3O4, this compound contains FeO and Fe2, Fe2O3. So these two compounds, ion have different oxidation states. In the first one, now in FeO, that means I don't know that of ion because it has different oxidation states. So you say X plus, it's already said that the sum of all of the oxidation states for a neutral compound will be equal to 0. So X plus, this one will be minus 2, will be equal to 0. So X is going to be plus 2 here. So that means the oxidation state of ion in this case is plus 2. Now look at it in Fe2O3. Let's solve for ion here. So we're going to have 2 into X plus 3 into minus 2 is equal to 0. So 2x is equal to 6, right? Then x is going to be 6 by 2, and that is going to be 3 plus 3. So you can see in this same compound now, iron has oxidation state of plus 2, and it also has oxidation state of plus 3. You can have a case like that too. This was asked in one of the post-UTME questions, that what is the oxidation state of nitrogen here? In this compound, I have ammonium ion and I also have NO3 minus. So what is the oxidation state of nitrogen here? And what is the oxidation state of nitrogen here? So if you look at it, this is going to be X plus 4 into, I told you hydrogen is always plus 1. So plus 1 is equal to the charge carried. That's plus 1. She get, I can say X plus 4 is equal to 1. Then X can be equal to 1 minus 4. And that is going to be minus 3. Do you understand that? So that means the oxidation state of nitrogen in ammonium ion is minus 3. Let's look for the next one in NO3 minus. So that will be X now. So this will be X plus 3 into minus 2 is equal to minus 1. So X minus 6 is going to be minus 1. X is going to be minus 1 plus 6, and that is going to be plus 5. So nitrogen has oxidation state of plus 5 in this place and oxidation state of minus 3. So it has two oxidation states in this simple compound, which is ammonium triazonitrate 5. So that's what we have here. So now, those are the rules you need to note. For the first one, just go back through all of those rules. Now, when do you apply these rules? You are going to see they can give you a question. So quick question. Look at this. In this question, you are going to determine which of the following compound or which of the following reaction is a redox reaction. So number one, let's say I have H2 plus O2 to give me 2H2O. So this is a reaction. So they will ask you in an exam that is this a redox reaction? So follow the rules I told you. This is how you will know. When there is a change in oxidation state, then that is a redox reaction. So hydrogen, I said something here that when an element is in the neutral state, that's number 4. When it's all alone, when it's not combined with any other element, then what will be the oxidation state? 0. So look at hydrogen here. Now, what's the oxidation state here? Is 0 because it's not combined with any other element. What do you think is that of oxygen here to 0? Then I say hydrogen in a compound, aside peroxide and superoxide. So hydrogen in a compound is always what? Plus 1. Then oxygen in a compound is always minus 2. So if you look at this now, this one went from 0 to minus 2. So there's a change in oxidation state. This one went from 0 to plus 1. So there's a change in oxidation state. That means this reaction is a redox reaction. Let me give you another reaction to C again. Cu plus HNO3 to give us CuNO3 2 plus A2O plus CO plus NO. Now, I don't need to balance the equation here. Let's just check. Is this a redox reaction? The moment you notice a change in oxidation state, then that is a redox reaction. Copper, what will be the oxidation state here? Very good. That's going to be 0. Then what will be the oxidation state here? If you check it, that's going to be plus 2 because this is like saying Cu2 plus and NO3 minus. So this has 2, then this has 1. So when you change it, that's when you form the compound CuNO3 2. Share you get. So this one is plus 2 in this place. So it has gone from 0 to plus 2. Hydrogen here is going to be plus 1. Nitrogen can have variable oxidation state. If you calculate for this nitrogen from the rule I gave you up there, then this is going to be plus 5. The oxygen here is going to be minus 2. Why? If you come to this place, this will be plus 5, this will be minus 2, this will be plus 1, this will be minus 2, this will be plus 2, and this will be minus 2. So if you look at all of the oxidation, you can calculate it, you can determine it the way I did it the other time. So looking at all of this now, there's a change in oxidation state. Copper went from 0 to plus 2. Nitrogen went from plus 5 to plus 2. If you remember what we did in the first class, I said, if they now ask you that which one is undergoing oxidation here, let's look at the first equation. This one went from 0 to plus 1. That's an increase in oxidation number. 0 to plus 1, only increase. So when it increases, that is oxidation. That means hydrogen is undergoing oxidation. Oxygen went from 0 to minus 2. That's decreasing. So that means oxygen here is undergoing reduction. Copper went from 0 to plus 2. That is what? An increase. That means copper is undergoing what we call oxidation. Nitrogen went from plus 5 to plus 2. That's reduction. That means this one is undergoing reduction. This one is undergoing oxidation. And remember in the last class, I told you that you should not pick your answer from the product. Your answer is always, so it's very easy to pass all of these areas when you know what to do and the principles. So let me to check and tell in the comment section if this number 3 question is a redox reaction or not. So NOH plus HCl to give me NaCl plus H2O. So look at what I have here. Tell me, it's not a balanced equation. That's not needed for now. Tell me if it is a redox reaction. Number 4. So tell me if number 4 too is a redox reaction. Let's say I have Al plus Fe2O3 to give Al2O3 plus Fe. So Al plus Fe2O3 to give Al2O3 plus Fe. So let me to check, is this also a redox reaction? Number 5. If I have H2S plus Cl2 to give me HCl plus sulfur. So is this also a redox reaction? Determine the change in oxidation state in all of them using the rules I gave you, and let's see what your answers are. When we are through with this video, I'm going to the next one, and the next one is redox. So we are going to look at redox. Then I will quickly teach you this for the purpose of those that want to know about it. Then test for reducing agent, and this, then we'll solve all the past questions together quickly. But make sure you write down. And one thing I want you to do for us is make sure you subscribe to our channel. You see the subscribe button below. Click on the subscribe button, then like, comment, and share. If you subscribe, it's not going to remove any of your money. So don't be scared to click on the subscribe button. You are not paying anything. Just help us to click on the subscribe button. You're also helping us to promote the videos, and you're encouraging us to do better. And when next we post, you're also going to be seeing videos of all of the things we do. So God bless you. We'll teach you up to the university level when you get to do some courses that might be so difficult for you. So make sure you subscribe. I'll see you in the next class.